Okay, for people joining the live stream, we are in the late stages of reviewing image and audio functionality for version 12 after last week having our technology conference, previewing a lot of stuff which seemed to work fairly well, and I got a cold, which I'm at the end of, and so I'm in poor condition here. All right, where are we starting?
Start with the image stuff.
Okay, image adjust. Do I need to update documentation for this?
Yes. You can assume that documentation changes all the time.
Right. This should have been done. Okay. All right. So let's just talk about. Okay. Did we resolve the design of image pyramid in the end? Because we were looking at that before, and there was some confusion in the design. Is that thought now to be done?
I think we're happy with this. We just wanted to run the whole all the three functions by you one last time, in case you want to see it. Nothing really has changed much.
Okay. Okay. I was asking in the previous meeting whether the facial features stuff had been, whether the smaller neural networks for that were in now.
No.
But that's in process?
Yes.
Okay. All right. So we'll start with image adjust here. Okay, what am I looking at?
The updated stuff are the named correction schemes, the ones, brightness, channel wise, and.
By the way, I note that. Oh yeah, it does work. Never mind. Okay, so hold on a second. So where is that? Oh, I see. Okay, well, this makes sense. These are a little bit obscure, if I might say so.
Symmetric ones are very useful when you get negative values as well. For instance.
But just let me understand the naming scheme altogether here. I mean, one thing says symmetric, one thing says brightness, but they're both. Wait a minute. So some of these affect some of the parameters and some affect others of the parameters. Is that correct?
Right.
Okay. So the first question about these is what? So channel wise. No, I don't understand. Channel wise is sort of a different part of speech from symmetric. Am I making sense? Roger, can you comment on this, please?
Yeah, you're right.
So we've got channel-wise symmetric. Okay, let's look through this. Okay, so global.
I mean, alphabetic is usually not the best order to grouping-wise necessarily.
Okay, rescales for the range 0 to 1. So is it the case that symmetric and global are the sort of things in, are those related? Are those the things? Is 1 0 to 0.5? I don't understand. Shadi, do you understand what these are all doing?
I do. Global is as opposed to channel-wise. So that's one dimension we're looking at, whether we are taking the min-max values of all the channels and map that to 0, 1, or do we do that?
What is the thing in neural networks that is the that's element-wise, is what we call it in neural nets, right?
Correct.
Okay. So what we've got here is we've got channel-wise. Okay, so I'm trying to understand brightness and lightness. Those are two things, yes?
Yes, and those are just adjusting for one channel, whether the B in HSP or L in LAB.
So, okay. So, but these here, this case is adjusting by a particular number, right?
Correct.
And what you're not doing here is to break these into an association where you say, gamma correction arrow, whatever, brightness arrow, whatever.
And okay, so what you're suggesting is that maybe we should actually say contrast for this channel or all channels.
I think I'm saying that. I'm suggesting that what happens here is that this breaks into some kind of association, and that, I think it's nice to have these short things, but I'm not quite sure that they're the right short. Global just seems unbelievably obscure.
I agree. Channel-wise is very clear. Global, I agree, if you have a better name for that. You see how the math works there, right? So we get min-max of all channels as if you flatten all the data values.
Yeah.
And then scale it to 0 and 1. Which you typically end up with a better scaling than if you do channel-wise, which introduces new colors.
Yeah, I get it. Okay. But global, I can't tell whether that's the whole picture or the whole, all channels.
Correct.
The word combined seems better than, I don't know what we have for other, and I don't understand the word symmetric either here.
So symmetric is when you have numbers that range from, say, minus 0.1 to 0.5, and then you want the 0 to be the absolute gray 0.5, which is a very common scaling.
Yeah, I understand. So then, I don't know why that's called symmetric, though. It's 0. What that really is centered around 0.
Correct.
It's more like 0 centered. But in fact, what you want is not 0 centered, right? You're taking it from the 0 centered case to the. This is super confusing because some of these are destinations, some of them are sources, right? Symmetric is a source designation here, right?
That's correct, yes.
Whereas channel-wise is not a source designation, it's something completely different. Okay, is it the case that there are just a set of parameters here? So what one says is, that it's essentially destination range, and then it's interval 0, 1 or something. Source range, blah, blah, blah.
That's the third, fourth argument that you're talking about, right? We already have those.
Oh, I see. Okay. Okay, well.
It's more about which channels to adjust,
Yeah,
and
but
then how to adjust.
Yeah, but okay, but so that's a replacement for. Maybe you should have a string name for instead of the ins and the outs here, right? Maybe instead of you could do that third argument. You could say 0 centered, or you could say automatic or something there, or something, and that would be 0, 1, right, for the in out.
Mm-hmm.
And similarly in the output, you could do the same thing. But then here, somewhere you're saying whether to treat the channels separately or not, right?
That's correct. So that's going to be.
But that's which is a completely different issue. That's a completely new feature of image adjust, if I'm not mistaken.
That's correct. It actually started as a separate function, and then it became this. We tried to merge it into image adjust.
Maybe it's an option to image adjust, whether to adjust all channels at the same time. Image contrast. Well, no, I see. This is really, that is kind of, yeah, this contrast, brightness, and gamma correction, those are really, so I don't understand. When it says rescales the brightness, but here it's giving the amount of rescaling, right?
Yeah, when we say rescale the brightness, it means rescale to 0, 1, which is the 1 arc form of image adjust.
Okay, how do you reproduce that by giving the 2 arc form? Rescale brightness to 0, 1. What is the 2-arc version of that?
There is no 2-arc form. We will have to color separate, color combine.
Okay, listen, I think this is a mess. Okay. Let's try to come back to this. I mean, this is not right. And my best compromise would be if we're absolutely running out of time, let's simply not document these things, this version.
Okay.
But I mean, it'd be nice to solve it. But I think this is not properly orthogonalized.
I agree with you.
I agree as well. Okay. We'll
so see if you can see. Why don't you do an iteration on it then?
Sure.
Okay. All right. Let's look at image pyramid. Okay. So last time, it's been a few months here, so I'm forgetting a little bit what the deal is with this. So how can you say create something formed from? Well, okay, so let's take an image here. Oops, let's take that guy. Why is that a single image?
It was large. We rasterized the whole thing.
Okay. All right. Okay, so now you say image pyramid here, and you get a somewhat incomprehensible creature. Oh, excuse me. Okay, so I don't really understand what that is. So how am I going to use this? How do I go from the image pyramid? Is that inverse?
Pyramid?
Okay, so if I were to say, for example, for these, if I were to say blur /@ each of those, and then I would say inverse image pyramid.
That wouldn't work right like that. You would have to say pyramid all levels equals blur, or you can use image pyramid apply blur and then do inverse image pyramid on that. But the goal
so this is so here, if I say, I see image pyramid apply of, let's say, binarize just for fun onto the image pyramid, and then I say inverse image pyramid as opposed to from image pyramid.
Correct.
Why is it inverse rather than from?
An inverse transform.
Is it really? I mean, is it nice mathematical properties of inversing?
I think so. I mean, it's effectively a junior wavelet.
Mm-hmm.
And wavelet has an inverse wavelet. I mean, it's some.
Right.
Yes.
Okay. I don't really know what I'm doing here. So how does it? Oops, what's that? What is that? Do we have a project manager here?
Yes, Stephen. Manu here.
Can you screen cap that and figure out what's going on?
1 sec. Done. Thank you.
Okay, and you got what I did to get that? Yes?
Yes.
Okay. Okay. So what happens if I mean, I don't quite understand. When I'm doing image pyramid apply, is that applying the same function to every? No, I see.
You can do both. You can apply the same function to all levels, or you can apply a function on a list of images from corresponding levels.
But how if I don't? What about if I don't know how many levels there are? Is there a default number of levels? And why can't I have a function who's like a map indexed, where the second argument is the level number?
We thought about having that as well. We just didn't. Well, we have it in the image context. If you want us to.
By the way, small issue here for Manu. This doesn't have its thumbnail here.
Okay.
You see that, right?
Mm-hmm.
Do you understand what I'm talking about?
Yeah.
Okay. All right. It seems unproblematic to apply f with 2 arguments here, but maybe that's wrong. No, that's wrong, because you couldn't then just say blur, right?
Mm-hmm.
What is the typical case that you want to do?
One of the one big category of functions is multi-scale feature extraction, like you want to do saliency detection, edge detection, and so forth on all resolutions or scales, and then you aggregate all the results.
Okay, but is that what this is doing, for example, here?
Yeah.
Yes.
And why is that doing? I mean, so wow. I mean, how do I know all of these things, like Gaussians? And I mean, what would happen if I just said, okay, so that's giving me the 4-level image pyramid. Is that correct?
Correct.
So, and I should use zebras because otherwise they don't have enough stripes.
Correct.
Okay. Okay, so now if I simply say inverse, I mean, I don't really understand what this is doing. So let's be Laplacian. So I don't understand what those, okay, I didn't understand that.
I'm suggesting we have some other names for inverse image pyramid type or goal. There are two very typical ways we would like to access data in a pyramid. Either just sample a level that has the right resolution, or aggregate or combine all the results. When we say Laplacian now, it means aggregate everything. So it upsamples, add to the previous level and goes all the way up.
But so I don't quite understand. I mean, in the inverse case, what you were doing here, if I just take %9 and I look at the sub-value all, I'm getting something which is kind of at some level like the inverse image pyramid, correct?
Correct. Yes.
That's kind of screwy. So on the one hand, subvaluing into the image pyramid itself gives images, and on the other hand, inverse image pyramiding. I mean, so if I were to do,
but not if your initial pyramid is a Laplacian pyramid.
What do you mean?
You can say what kind of pyramid you want to construct. Take that zebra and say image pyramid, comma, Laplacian.
Okay, so now this zebra will be more black and white even than the zebra. No. Oh, okay. So did you see this output and this output, right? That's what generated this self-test error.
Okay.
Did you get that? Right. So let me send you. You're going to need to pick up in this. Let's see if I can just send this to you.
Mm-hmm.
Right, because otherwise we won't be able to reproduce this, and that won't be any good. Oh my gosh, this thing is barely. Oh my gosh, it freezes my mail application trying to copy paste this. That's not a good sign.
Steven, I can take a screenshot of that.
Okay, but then you have to know where this comes from. Inverse pyramid apply, etc., etc., etc. Wow, it just crashed my mail app. That's exciting. Okay, but so what are these black things here?
These are the differences between levels of the downsampled image. If you open image pyramid itself,
well, actually, I can see there's a very ghostly zebra here.
Yep.
So if I say image adjust, for example, on that ghost zebra, I see. Sorry, what are you saying? If I open image, which one?
Image pyramid. Under details, there is an illustration that shows the two main types.
Okay. Right. That's blurring, that's differencing. Is that right?
Correct.
What does that mean? Low pass, comma, Gaussian? That's not two arguments, is it? Why isn't that on the list?
There are synonyms, and the reason why we added both is that Gaussian and Laplacian are very well known in the literature, but then you may want to define other kernels, like what you can do in the third, fourth rows of that table. So in those cases, they're technically not.
Okay, I would recommend for this documentation, comma or would be better than comma here because it's a bit confusing.
Oh, okay. All right. Makes sense.
Okay, so let's see. So where were we here? So we were at the question of whether inverse image pyramid. So you claim that that's like inverse wavelet transform.
Yeah.
Yes.
That it goes back from an image pyramid to an image, which sounds reasonable to me. But it's very weird that we're going down as Gaussian and back up as Laplacian. That's really weird.
Well, it's a hack. See what I'm saying? It was for that application, and I don't think it's super appropriate as a basic example, because I think there needs to be comment that explains, how you use it.
Fine. Because otherwise I would imagine that the default inverse image pyramid would be to recover the image assuming the same pyramid type.
Yeah, exactly. So, and often the thing that you want to do some operation at different scales, like a blend. There's a typical classical example is blending at different scales.
Yes.
Or you might do some filtering at some very.
Well, so if you want to do it at different scales, is it the case that you can just do that at a particular scale?
Yeah.
With pyramid apply? How do you do that? Because you'd have to say identity, 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 blah, blah, blah. Doesn't seem right to me.
That's where something like image pyramid apply indexed would be useful, or map indexed.
Well, I'm not even sure that's the right way to do it. I mean, why not have some kind of sparse specification here where you just say 3 arrow and then the function to say do it at level 3?
Yeah. If it's just a one level setting, we also can do the L value setting. You can say peer 3 equals blur of peer 3.
What are you saying? Peer 3? Oh gosh, some L value insanity.
I thought we agreed on the fact that they're not insane.
Okay, I don't like it, but in any case. I mean, look, I don't think this is a fantastic design. I mean, I know we went through this in some detail, but I think, I don't really understand what would cause one to do a blur at level 3, for example, or a blend at level 3. What would that then look like if I just adjust what happens? I mean, again, it's very, very inconvenient what I'm being asked to do here, right? Because in this case, if I go, let's say Gaussian here, and do I need to say the word Gaussian before I say 4, or can I just say 4? No. Is that really right? Seems like, okay, so I've got the Gaussian thing. Now what I do, it keeps on generating those self-test errors. So if I say image pyramid apply, and then what I'm going to have to do, wait a minute. Can I give a list of functions there? No. How do I change what happens at different levels? Or is it always the same function being given to every level?
Very typically, it's the same function that you want to apply to different scales. But again, something like image pyramid map index or apply index would be the way to specify.
Yeah, but that seems really grotesque to have to do that. I mean, one possibility.
The other common thing that you may want to change when you go from a level to another level is to change, say the scale or range specification, which then make a lot of sense to actually be able to do it with image pyramid apply index.
Sorry, the range specification of what kind?
Say the radius for blur.
Yes, it makes a lot of sense to want to do that. Right, depending on the size of the image, for example. I mean, I could do that by just looking at image dimensions, right? The F function could look at image dimensions.
Right.
And maybe you should document that that's possible.
Okay, we will.
I mean, that seems like it's the, I don't even know. I mean, when you make an image pyramid, is it always a factor of 2?
We have a scaling factor after the n levels. After that 4, you can say what other factor you want to use.
Okay. These functions seem a little raw to me. I would recommend that we make them experimental.
I agree.
Okay. Let's not obsess about them right now. I think we should pick them up again later. They're probably okay for right now. We have a question on the live stream about, does it support pyramid blending? I think the answer was yes, right? That's the multi-pyramid case.
Correct. We have an example under image pyramid applications.
And a suggestion here, the classic orange to apple blend would be a nice example.
It's
That's
there.
the one. Yeah, that's the one we have.
Under what?
Image pyramid. Go to applications, effects.
Merge the 2 images at all scales. I see. That's an app orange or something. So, okay, so this is, so why are you even showing this? I mean, this is just, that has nothing to do with image pyramid, this thing up here, right?
No, this is just taking the left half from image 1.
Yeah, okay. Okay.
A function in the repository.
Okay. So what is this doing? This is an image pyramid. I don't understand this here. Map. What is the 2 now?
We are getting 2 pyramids from apple and orange. I agree we should probably just split this into orange pyramid, apple pyramid. Just make it easier.
Yeah. And I don't understand what split merge is doing here. This is just super confusing to me. This is just super confusing. I mean, this is just using the same function, which arguably is a function that would be useful to have. I don't know. I mean, I'm amazed that it's so complicated to do that. Why is it so complicated to do that? Why isn't that just some image take of scaled over half or something?
You're right. Maybe we have scale. I don't know. I'll look into it.
Okay.
And if not, it makes sense to add image takes scaled.
Yes, I would think so. Okay. So anyway, pyramid stuff will be experimental for now.
Do we want to at least quickly talk about the name image pyramid apply? Should it be image pyramid apply, which comes from image apply function that we have, or image pyramid map, and then eventually maybe image pyramid map indexed?
You know, the image apply is a element-wise application, right?
Correct. Pixel-wise application.
Yeah. I do think image pyramid map would be better. Question on a live stream, any chances for virtual image stack for handling, displaying, and processing big images? I think we have a bunch of things, but that's not related to image pyramid, is it?
We are going to have a backend of image pyramids, possibly as a new modality or internal representation of images, which is going to help display and processing of large images. But that's not.
So by virtue of having sort of the low-res version come in earlier, the low-res version is easier to handle in core, so to speak, with the high-res version deeper in the pyramid being on a file. Is that the idea, or what?
Something like that, yes. Or everything being on file, but then accessing the low-res is going to be much faster.
Okay. Yeah, point being made here. Another use of image pyramids is creating a high-fidelity image from a set of images taken with different focal lengths shutter speeds, etc. I'm not specifically aware of that. I don't quite understand that. Maybe, I mean, that requires that you take a bunch of images and essentially reweight them into an image pyramid, if I'm not mistaken, by saying this image is higher resolution and more important. These other images are going to be washed out by being at different levels in the pyramid. Or maybe I'm confused. Can you comment on that? No?
I'll look into it. I took a note.
Okay. Well, okay, so these are going to become experimental. Roger, what do you think about changing it to image pyramid map?
Well, I think it fits better with the rest of the language and with wavelet map and so on.
Is there a wavelet map?
I think so. I forget what it's called. Let me look.
I thought it was wavelet apply, actually. But
well, let's look that up.
There's a wavelet map indexed. Okay. But is there also a wavelet? That's interesting. There isn't a wavelet, so maybe there should be an image pyramid map indexed.
It's kind of more important for wavelets because they're bigger. You know, you get sort of 4 images every level down.
So?
No, I mean, we designed it that way because exactly for the discussion we had here, which was to be able to focus in on certain areas.
Right. So I guess my question would be, in the image pyramid case, is it ever useful, other than for demos, to apply the same function to every level?
Yeah.
Why?
As I said, one of the very typical examples is computing some features at different scales.
Yeah, but how do you recombine those? You mean features as in like that edge detection thing for the zebra?
Right. Or for instance, salient regions, right? And then you really want to blow up the significance of a small region at a small scale. If it's
okay. But what this suggests to me is that one could imagine something like edge detect, right? Like a scale invariant version of edge detect. That's what you're saying.
Yes.
But then maybe we need an image, just forget pyramids and unpyramids, package that up and basically say, scale invariant image apply or image map of edge detect, and have something else deal with that. See what I'm saying? So it automatically creates the pyramid, does the application, reassembles it.
Mm-hmm.
That's the operation one's really talking about.
That's a good idea. Do we then want to have rotation invariant functions as well? Translation invariant as well. Yeah, I think.
Well, so what those would be is, what you're saying is, if there is say a corner detector, right? That you want, what's that?
Yes.
Then you could imagine just having a mechanism that just says, apply this corner detector with translation, rotation, and scaling, accounted for, so to speak.
Correct.
That seems useful to me.
I agree.
I mean, honestly, it seems more useful. I don't know, right. Okay, let's make image pyramid experimental. So the only question is whether it's image pyramid map or image pyramid apply. Roger, what do you think? Or map indexed?
Well, I've always been slightly confused with image apply. However, we arrived at that at the time.
It was because image map kind of feels like geographic maps. That was the argument behind not calling it image map.
Okay. Hey, Roger, I have a practical question about the polyhedra meeting that's on the agenda for later today.
I think maybe you should cancel that because I can't guarantee that things are going to work.
Okay, well, so then in that case, what we should probably do is move the LCC meeting into that slot if that's possible. And then we can continue with this because we've clearly got more to do here. Can someone figure that out, please? Can we do that? Okay, all right. So then we're going to keep going here. And we'll hope for polyhedra like tomorrow-ish.
That's
okay.
what I think. That's
okay. All right. So okay. Well, image pyramid map. Okay. So image pyramid map or map indexed.
I would be comfortable with both.
We don't want to have both. It's a mess. I mean, we don't have both for wavelets.
So one thing that I was worried about is that this pyramid would introduce a whole stack of functions around it. There's like a whole, basically,
pyramid of functions. Yeah, no, go ahead.
Right, just a bunch of code administration functions. Map this and that, do this and that.
Yeah.
Which is, not so good.
No, it's not. I mean,
I do think it's a little bit raw functionality, but it's also very promising functionality. As some of the people on the stream, I'm sure, knows great applications. We know too. We just don't. I don't feel it's.
All right. Let's leave it as image pyramid apply for now. It's an experimental function. It may get, revised into something else. I don't think we're ready to figure out map indexed, etc. And in fact, my guess would be. Yeah, I mean, I don't even know how successful the design of the wavelet stuff is. Do you have a sense of that, Roger?
Well, the big downside was that our timing wasn't great for wavelets, and the key applications. I mean, it's actually very powerful, but they require some learning on the part of people. So some key applications we don't really care about, like compression. But compression has been sort of a key driver for wavelets. But who writes their own compression algorithm? I mean, you're going to use, and then there's sort of feature detection at low levels. Like you can actually find discontinuities very reliably with wavelets, or differentiate very reliably. So it's powerful.
But are we using wavelets in our other functionality?
We're not.
Maybe we should.
But we.
I mean, like our. I mean, in some of our feature detectors.
We should, yeah.
We should, and it's so image processing team has taken over wavelets. So we're going to sort of gradually start to absorb and integrate.
What about on the audio side?
Same thing.
Same thing.
Okay.
Yeah.
Okay.
And we've updated them so they actually support the new audio objects. Because we built them to support sampled sound back then.
And then added audio in 11.
And then we added audio now that we have audio.
Okay.
So we did them for both audio and image at the time, but it was just it needed to be updated.
Okay. All right. Let's keep going. So the conclusion is it's going to be in there, experimental with image pyramid apply.
Sounds good.
As designed here. Okay. Need an option to specify maximum allowed overlap, max overlap fraction.
This is what you suggested in the machine learning meeting.
Fine. What does this mean?
This is whether we want, so for find faces, it doesn't make sense because the only object we are detecting is faces. But in image contents, the question is, do you want to get overlapping cats and dogs, but don't want to have overlapping cats? So we haven't really designed or implemented this, but it would be nice to have a setting for max overlap fraction that says, do we want the overlap to be computed globally across all classes or only?
Right, but I mean, this seems like, okay, so look, for each class, right, you could imagine an association here that says cat, arrow, whatever, right? Mm-hmm. You can allow jellyfish to overlap because they might do, but you can, because they're translucent, but you can't allow cats to overlap because they're not translucent somehow. Well, that's not really right anyway. There could be a cat partially obscuring another cat. Bad example. But I mean, I would say it would be either the max overlap fraction or an association for the different types, or, well, I don't understand what this single global thing is. What does that mean?
Again, just global across all classes with the default threshold T. which is typically a 50% overlap.
Okay, this is incomprehensible to me. I mean, in other words, to me, it seems like what you should be doing is saying either, right? So it's either, okay, so max overlap fraction. Okay, 0.3, so or point whatever it is, okay, 0.5, fine, whatever. So that's the fraction of the bounding box or the fraction of the mask?
Bounding box. If we have bounding box, eventually we could have, currently all we have for image contents and fine faces is the bounding box. Eventually it could be the refined shape.
That's going to cause an incompatibility, isn't it? I mean, in other words, we have to decide whether the overlap fraction, what determines whether the overlap fraction is measured with respect to the bounding box or with respect to the shape. Get what I'm asking?
Yeah.
Okay, but separately, to me, it seems like the right thing here is we're saying things like, dog arrow, whatever it is, dog arrow 0.7, whatever, right? And where the default would be essentially, well, either blank arrow, whatever, anything is 0.7. But now I don't understand what you mean by this global, which probably should be all.
I think the more specific syntax is going to be dog can overlap with cats, but not with snakes or something like that. How do we specify that if we want to be specific? If we don't, I guess the two settings we had in mind was either really check for overlap across all classes or only within the class, the detected class.
Okay, so wait a minute. So, okay, within a given class, so that's cats with cats.
Mm-hmm.
Okay, that's globally across classes. Cats with anything. Well, anything with anything.
Mm-hmm.
And finally, specifically between classes.
Right.
Well, I mean, seems to me that you've answered your own question here because basically what's going to end up being would be something, I mean, it's kind of complicated, but if you need it and we can give it, you might as well give it. I mean, something like this: cat, dog, arrow, whatever it is.
Mm-hmm.
And then one could imagine things like cat, all.
That's doable.
But what is the difference between cat, comma, all and just cat on its own? So cat on its own is cat with cat. Is that correct? The default, in other words, dog arrow 0.7 is equivalent to dog, dog. Dog eats dog, so to speak.
Yeah.
Okay. Now, where, fine. Okay. Well, I mean, is this implementable?
I think so, yes.
Okay. But then those categories might be at different levels as well. So
I was thinking about that.
That's okay. That's fine. I mean, animals can overlap animals, but they can't overlap trees. All right, fine. I mean, what we get for this version might be, so hold on. What is the meaning of all here, which is what I think global should be?
Mm-hmm.
If it isn't,
I think the default T should just be overlap between all classes.
Yes, I agree. Anything with anything, basically.
Yes.
But I mean, there'll be a separate argument that determines what you're looking for. Are you looking for animals or plants or whatever?
There is a category, yes.
Right. So that's what you consider. Then, okay, so question. If there is a category not being searched for, but which an overlap is detected with, what happens? In other words, if you say, I only want to look at animals, I'm using image contents just with animals, but there's an animal overlapping a tree, what happens? Or a tree overlapping an animal, what happens?
I guess we don't eliminate it because we don't look for
Because we're
the
like
tree.
blind to the tree,
I
basically.
think so. I think
Okay.
that makes more sense.
Okay, fine. Then what is the meaning of this global thing here? I don't see what it means. I mean, in other words, it's saying, because that seems like that's what this is doing. That's the faction.
Is that global equivalent to 0? No overlap?
No, I don't think so. Shadi said it was the default overlap.
Right.
So I don't know what the global means. I think we should not do it.
Okay.
And I think for this version, we should just have a single number. And for in the future, we should have this binary thing like this.
Okay.
Make sense?
Yep.
So in fact, the default. Okay, so this is a little tricky because what you're telling me is the default, the T thing is this. But what does all mean? Does all mean all, or in other words, is all equivalent to essentially x blank, or is it equivalent to blank, blank? Get what I'm asking? In other words,
blank.
okay.
So there are no two detections that have more than T overlap.
Right. So that's true for any. So then the only question would be if you would care about self overlaps, but not, in other words, about the case x blank, as
Correct.
distinct from the blank, case.
Right. Which your first syntax up there, dog goes to a single arc, dog goes to 0.7 is convenient to specify that. And then I think it would be useful to give that a name so that, or maybe we just say underscore goes to 0.7.
For which?
For the case that we want to say within a single class, we don't want overlaps.
Well, I mean, there is another name we could use, which is an any. I don't know. I mean, we could also use the pattern variable, pattern case. I think this is immature. I think we need to work this out later.
Okay.
Did you capture this notebook, or should I be storing it somewhere?
I did.
Okay, chromaticity plot 3D.
If you open colors near, there is an evaluated version. I don't think I've ported it here.
Okay. That's pretty cool, actually. That's color space. Okay. Where's it spherical?
If you would have to specify the distance function, the third argument of colors near, so that it is the Euclidean in LAB.
But wait a minute, when you say colors near here, isn't there a more minimal example than this? I mean, can't you just say, I mean, shouldn't you show an example in basic examples that says, that does a green screen or something?
That's right. I put that under applications. You're right. I'll bring one up to the main examples.
Okay, but are you saying here, so if I say chromaticity plot 3D, well, actually, let me just do chromaticity plot to start with. And then I'm saying, colors near red. So let's do this as the most basic thing. Okay, I don't understand what happened here. Why don't I see some?
If you do chromaticity plot 3D, you're gonna start seeing.
No, but why don't I see it for chromaticity plot?
Well, Julia and I have talked about this a lot. The default is, well, maybe we should project already as well. The question is that, do we want a cross section of the 3D plot, or do we want a projection of the 3D plot?
Okay, colors near represents a family of colors near red, correct?
Correct.
Okay, in the 2D, whatever those colors are, put them on the 2D chromaticity plot. I don't understand. I don't know what shape they're going to be. You have to tell me that. I don't know how it projects, but there should be a shape in the 2D chromaticity plot that represents colors near red.
Right. If you add a 0.3, comma 0.3 to your chromaticity plot, you're going to start seeing cross sections of the 3D shape. Currently, what you're seeing is at luminosity level 0, so the bottom of the shape. So this is currently a cross section.
I'm totally confused. Luminosity, what? I mean, this looks like a bunch of colors. Why is it luminosity 0?
Open the page for chromaticity plot.
You're missing a dimension, Stephen. So
yeah.
Yes, I understand that. But so what?
So you're looking at a different slice now.
If I might say so, this should surely be the minimal example. Something like this should surely be a minimal example for colors near, rather than that much more complicated thing.
Okay.
And if I might say so, these seem like crummy examples for chromaticity plot. You should just give something where you've got a list of colors. Right? I mean, chromaticity plot, you should be able to, unless I'm very confused here, chromaticity plot of something like, or an image, actually. You should show, these are silly basic examples, if I might say so. It should show an image here, the chromaticity plot for an image, because that's the #1 use, rather than these very nerdy things about wide gamut RGBs.
You're right. These are the color scientists who care about these things a lot. But for us, yeah, we can do that. I'll change those.
Okay. Well, I mean, you can include one of those as well, but okay. So I can barely see those points, but they are there. Okay. So explain to me why colors near red. Okay. So I am totally confused now because red is showing up in this picture. So why aren't colors near red also showing up in this picture?
If you have the chromaticity plot 3D, right? Or read the text above the illustrations in chromaticity plot. It says we are getting the intersection and one intersection. Oh, if you open the details, sorry, I was looking at my own documentation. Displays a slice given by constant luminance 0.01.
I don't understand that at all. I mean, if I take a picture of a, let's say I've got, picture of an elephant. Okay, what I'm looking for here is that elephant. Hopefully I'll get a picture of the African bush elephant. Okay, fine. Okay, so what I had understood was that the cluster of pixels that I see here correspond to, I mean, in this picture, there are pixels displayed of a certain color.
Correct.
What I had understood was I'll see a dot for every pixel in this image at the position in which it occurs in that colored image, in that chromaticity image. Is that
Correct.
right?
And this is projected.
What does projected mean?
Well, the colors are in the 3D space. They don't all have.
Oh, I see what you're saying. I see what you're saying.
So, 0.
I see what you're saying. So, in other words, these colors are flattened onto this chromaticity plot because we're ignoring their luminance.
Correct.
Right.
Okay, I get it. Am I going crazy, or is the font for this for the numbers here different from the usual font? Is that something completely nuts? Yeah, it's different, isn't it?
I don't have your eyes for this. I don't know.
Well, it looks lighter.
It looks a bit lighter. I agree.
I mean, it might not be wrong to make it lighter, I suppose.
I would be very surprised if we are changing it,
Okay,
but I'll double check.
Yeah, I don't think it's obviously wrong the way it looks. It just doesn't look the same way that it normally looks. Okay. So I think I understand what you're doing here. So now explain to me why the colors near red doesn't similarly project itself onto luminance 0 effectively, which means that colors near red. So I'm saying the colors near red would be some ball of colors that have certain luminance associated with them, but then you're ignore the luminance and just project them onto the 2D chromaticity plots.
We can do that. Julia and I discussed this both ways. We couldn't really agree which case is a more dominant wanted case.
It seems to me it's utterly confusing to not have to not have, I mean, if I say colors near red, it's like I could have for example, when I say colors near red, if I were to visualize that, I could have is there in fact a way to do that, to make an image from colors near red that is effectively a randomly chosen? Okay, so if I say random image.
That. We would like to have random sample, random variate from a colors near. That would be very useful.
Okay, so random image could have that as a distribution there.
Correct.
By the way, Manu, can you report another thing that is driving me crazy, which is that when I am doing this, okay, I'm not getting the cursor on the raft is not changing.
Okay.
Okay, so what I'm suggesting here, and maybe you already have that right now. Okay, so you have a distribution there, and the question is whether the distribution, where is the distribution specified?
It's just any random distribution. Any of our existing.
I see. So min-max could be colors near red.
Correct. That first argument, we should accept colors near.
So, but in particular then, for ordinary distributions, if you want something which says numbers around 0.2, numbers around 0.7, etc., I don't think we have an easy way to do that, do we, Roger? For standard statistical distributions, that is essentially a bunch of step functions around given, or intervals around a given value.
Uniform?
No, I understand, but if you want several uniform things, right? So let's say I want something which is, a blob around red, a blob around green, for example. How do I do that with distributions? How do I combine those distributions?
Okay, so there are many ways to combining. I'm thinking of what's it called, split. Hold on 1 second.
Okay. Well, in any case,
so there is a common case like that, which is often used to sort of take a distribution but have a different tail for it. So the body is one distribution, the tail is another. Is a very common case where you have several. And we built one that does just that. Perfect.
Okay. Okay. By the way, on a live stream, a question from Ali Hashmi, who says they have a user of image processing functionality, wants to ask whether image content can be used for annotating objects in images. Yes, the answer is yes, image contents. If you're asking, does image contents have convenient ways to have great. Why isn't it in there? Image contents documentation doesn't seem to be there.
Yeah, it hasn't. As soon as it's retrained to actually return a decent number of classes, we're gonna document it. It's in CVS.
Spliced distribution is the one that allows you to splice different distributions.
Okay. All right, so several things here. So image contents, first question is, can you take image contents and can you annotate the image with an image highlight type thing? Question.
Yes. If you get the bounding boxes, we can highlight.
Well,
things.
so wait a second.
I think that the implicit in that user's question is something that's highly interesting, which is to speed up image annotations.
Correct.
Okay, so build more streamlined, because it's super slow to annotate images, right? So to speed that up would be not too hard.
Well, I think there's a different question, which is, can you take the result, the data set from image contents, and immediately feed it to image highlight, so that you can put in highlights that say, that have a bounding box around the dog and say dog, for example.
Yeah. We have a prototype of that. It's coming.
Okay, so for image highlight, so that's a
yes.
But also related to that is like image tagging. You're going to tag different parts. I
think that's what we're talking about here, if I'm not mistaken.
Yeah.
Okay.
But what on earth is this message, by the way? Okay. Cat and dog here. Okay, so then the workflow that we're expecting here is something where you literally say image highlight. What is it called?
Highlight image.
Highlight image. Highlight image, right. Where you say highlight image, and then you give the original image here, and then you give that association. Is that correct? Or what do you give there? To highlight?
Even the function image bounding boxes eventually, which is an association of dog goes to the rectangle.
I see. So that instead of image contents, if I'd said, and there's something horribly wrong with the selector, image bounding boxes of that image, correct?
Yes. Oops.
What do I have to say here?
Oh, maybe, yeah, the category, dog. Well,
should it default to all?
I think so.
Yeah, I think so too. One argument form should exist then. Okay, so given that, the question is, does this work?
Not now. Not now.
Okay, but that will.
Yes.
Okay, I mean, that seems nice to me.
And then like many other demos we have seen or shown from these guys, all the cats are going to be colored the same color and so forth, which is visually very... So you put bounding boxes around cats as purple and all dogs are going to be green and so forth.
Yeah, right. I didn't, but the cat itself has not been painted.
No, the bounding box.
Okay, fine. All right. This we could call this the self-driving car, image, so to speak.
Yes.
I'm still trying to figure out what causes my car to think that the thing in front of it is a deer. It has an icon for that, and I just want to know what its catchment area is. Anyway, never mind that. Okay. What's that?
Autoleave build these image safety systems that are broadly applied to vehicles.
Okay.
Which we worked on from MathCore.
Okay. So it may be our tech that's actually determining the deer. It's always amazing that the technology goes in at one level and then at some point one becomes a consumer of it and one has no idea how it actually is applied. Anyway, okay. So question from Sandra on the live stream: random color of colors near red. That's a reasonable idea.
Yep, noted that.
Yeah, that seems like a thing that should work.
Correct.
Okay, Roger, do you have any objection to this thing about crushing the about projecting? So what will this look like if you project colors near red? I mean, I don't know what's going to happen if I go. What happens here if I go 0.5 or something? Disappeared again. Why did that disappear again?
You're not at that level anymore.
At what level? I don't understand what level we're talking about here. So I mean, if I say level L or something here, and I say L from 0 to 0.5 in steps of 0.1, what am I going to see here? I'm going to see a bunch of errors, but I don't understand what this airfoil-looking creature is.
This is really the cross sections of the 3D blob. Just
look at the 3D version of it, so we can visually see where it is.
Okay. So then I don't have to give. So I just say chromaticity plot 3D,
correct,
colors near red, and that's it.
Yep.
So let's see where it lies. But then you want that gamut too. So you probably want to add in the
RGB.
What do you want to do in RGB space?
Yeah, no. In the first argument, you can do that as well.
I'm now totally confused. Okay, yes. So that's where that is in RGB space.
Correct. But what Roger was suggesting was putting them in a list in the first argument.
Okay,
Colors near red.
Listen, I am firmly confused here. Okay, so the red point is over here at red value. Why is this? What is this? A solid filled-in blob? I don't understand. I'm really confused.
Well, it should be solid. It isn't visualized as solid. Do you see what I'm saying?
But does it lacking its edges here? I mean, is it lacking its faces because they're at the bounding box?
I don't know whether that's. I think that it's visualizing the boundary of it, and
okay. And why does it have that weird hole there? What is this shape? I would expect that in RGB space, this would be some fairly uniform thing.
No. It's all in perceptual space, Dion.
Yep. We're using the CIE 2000 color distance.
And there's
for
a
this
weird.
by default.
Okay, all right, fine. Okay, so
The
why the heck
hole
does
might
it
be a
have that
bug.
hole? Yeah.
Yeah, that might be a bug from our end, but the shape is not a bug.
Okay, so this is colors perceptually near red,
Yes.
right? Okay, perceptually near pure red, basically.
You have to remember, RGB is physics, has nothing to do with perception.
No, I realize that. Okay, so let me just try to understand again. So you're saying, so this picture here is a squashing down of the.
But you can see it, Stephen. If you do the list,
Okay.
string RGB, comma colors near in chromaticity plot 3D.
Well, let me just
and
first
get rid of that.
Well, I want to see this case. This is going to be somewhat pathological, isn't it?
Mm-hmm.
What the heck is that?
So
this is just the default plot range that is used. Notice the axes ticks.
Why is B from -4 to -2?
Yeah,
well,
that's how that colors near red is defined.
So colors near red has support for negative values of RGB?
It does. It's just a transformation from that CIE 2000 color space to RGB. We don't clip. We avoided clipping in many places in the system. It just helps us preserve the values when we're round tripping between color spaces.
Okay, fine. All right, so how do I show, so can I say plot range arrow RGB or something here?
That's not supported, but you can say plot range 01.
Okay. Shouldn't we have plot range arrow RGB?
But then plot range arrow LAB is not really well defined because it's not bounded space anymore.
Okay, so what do I do? Just this?
Yep.
Okay, what on earth am I seeing here? Okay, so RGB.
Probably we need to have 3 of those if you want to.
Right. So what's happening here is that so that's in R space. So that cuboid thing is the boundary of RGB space.
Correct.
That's the 0, 1 RGB space. Yeah, it makes sense. RGB, yes, exactly. That's 0, 1 RGB space. Okay, that intersects the near red, which is this weird airfoil shape with a slightly serrated pieces. It looks very, I mean, what is it? Is it an interpolating function? What is that thing?
For LAB, we are representing this as a parametric plot. So it's nice looking in all of that. In all other spaces, this is a region plot.
Why isn't it an interpolating function?
We don't have, why would you have an interpolating function in graphics?
Fair enough. Okay, so it's an implicitly defined region of some kind.
Right, but I really shouldn't use region plot. I mean, I've told you that many times.
Yeah, but we couldn't. Yeah, it's
Well,
not.
you should use parametric plot of some kind.
Yeah, that
or maybe it does.
Or contour plot, but contour plot.
You're basically saying resolve it so it's not a set of inequalities.
Yeah.
Yeah, but region plot solves a much more general problem.
Okay, all right. So the question here is, if you were to project this, if you were to show this in the 2D case, should you project all? I mean, to me, it seems like it makes sense to do that, to project all the things, you know.
But can get rid of the last RGB argument to RGB plot 3D so we can see how it relates to the gamut, the 2D gamut that's shown, because that's so confusing otherwise. Now. Okay. Now,
from live stream, someone is suggesting, by the way, color project as an option, true, false.
Yeah.
Yeah, I guess that would resolve it.
The other thing is that for the luminance level that we picked 0.3 earlier, we can use that slot and say all or some string like project if you want to project, and that could be the default if you want.
Sorry, I'm sorry. I
what?
The chromaticity plot, the 2D plot, has this luminance level that is that defaults to 0.01. That was the one that Stephen, you were putting in your table.
Yes.
To see all the levels. That argument, we can accept things, a predefined setting like all, or project, a string project or something like that as well, so that we explicitly project. And that
What
could
is the
become
difference
the
in
default.
projected and all?
I guess we can use them as synonyms for this case.
Okay, so wait a minute. This is an XYZ chromaticity space, is that right?
Yes, XYY.
Okay. And that's the boundary of RGB in that space, showing also the lump of perceptual colors near red.
Yes.
Okay. So now to get the 2D version, what is the projection that's done?
Look at it from the top, projecting on little x, little y. Yep,
Okay.
something like that.
Okay.
But notice that we don't project now, we actually get a cross section. So if you ask for our chromaticity plot of RGB, you get a triangle.
But we are projecting. I mean, in other words, for the elephant that is being put in that particular room,
right.
It's some, we're taking all the pixels of the elephant and we're projecting them onto that XY plane. Yes?
Correct. Yes.
Okay, so I don't understand. If we're doing that, if we're projecting the elephant, why aren't we projecting colors near as well?
We can.
I think we should.
If we think, okay.
Well, I mean, if we're projecting, we got to be consistent. Either that, or you could say of the elephant, show me only pixels that are between capital Y value of 0.3 and 0.6 or something, which we don't currently support.
What do we want to do then for color spaces like RGB? Like exactly that gamut that you're showing now. Should that as well be projected by default? And then if we explicitly ask for a luminance level, we slice?
That's a question of expectation there. Because
I don't know.
The one we show now, right, for the gamut, that's sliced, right?
That's sliced, yes.
Well, it looks standard like what everybody expects.
That's what everybody expects.
But arguably, the gamut could be different. Gamut is like a base, and then these things above it, like the elephant's pixels and things, are those are being projected. I mean, look, we've already crossed the bridge of projecting things by projecting from. So I think any of the content should be projected.
Okay, all right.
But the gamut should not.
Okay.
Okay. So. Okay, let's zoom out here. So the projection question is that second argument to chromaticity plot. All would mean project everything, I would assume. Now, I don't know about the base gamut. That's a separate issue. I don't know whether that looks silly if you project it. Now, a value 0.3, I don't understand what that means because, for example, for the elephant, if I were to go back to my elephant, wherever the elephant got to, okay, and I were to say chromaticity plot of the elephant, comma 0.3, what is it going to do?
The chances of you hitting any point. This one still projects.
Okay, so that's kind of inconsistent, right? You got to make it up your mind. And I think what this should do is, I think that second argument is kind of wrong because that second argument is only applicable to these sort of,
gamuts.
Whatever. Well, these things which have which have a higher dimension, which are higher dimensional objects. These points, you're not going to hit a point ever. So it's these higher dimensional things like colors near, which is a 3D object, or the gamut, which is also a 3D object.
Correct.
So what is in that second argument in general?
Reference space or reference space and the luminance value. You were trying RGB as the reference, but that could be the default is XYY.
Okay, so reference space makes sense because it's a 3D thing. I mean, this thing of 0.3. The problem is it's a you know, you're defining the coordinate that is not being plotted explicitly in the chromaticity plot. You're giving its value here, right?
Yep.
I mean, presumably you really should give an interval of some kind or something, or, greater than that. I think this is a mess, that second argument there. Roger, your comments?
Well, I tend to agree with you. I think that the slice is valuable too, but I think we need to look at that more systematically now and design a subsystem, Shadi.
And I like the interval suggestion.
I do too. I think that there are many things, we have these things, the slice plots that we built now too, where we look at things also in this.
Is there also the function form greater than of 0.3 and things like that is another, I don't know if that's the right way to do it.
But I think that what we concluded here is that we want to sort of expand out that subsystem and make it, consistent, systematic. And
live stream is asking about this. What is this going to show? What the heck is this? This is some kind of eclipse.
Yeah, this is like when you live in 2D space and 3D impinges on you. Flatland.
Yeah. Yes.
This is a growing neighborhood around red. The I that's specified is the radius or the distance from red.
And this is just showing. I mean, there's nothing particularly. This is showing that for some values here, I don't even know why it's piecewise linear. Oh, it isn't really piecewise linear. It just
that's the resolution, right?
Okay, but what this is showing is that as you increase the distance in the red ball, so to speak, you are eventually hitting luminance value 0.01, right? So this is effectively a conic section in some sense in color space, if I'm not mistaken.
Yeah, that's right.
It's not actually a cone, it's a spherical section of somehow in color space. Okay, so I don't think that's as confusing as okay. All right, let's just look at some comments from the live stream and then we'll move on to the next topic. Manually annotate. Can you manually do annotations with like this? Absolutely. If you can feed in this association to highlight image, you can feed in your own association as well. By drawing a bounding box and having the bounding box associated with some label. Yes, I assume this way, exactly.
But there isn't label support right now. It's coming.
For the bounding box?
No, for
images.
Highlight image.
Right. Okay, fair enough.
But what I was also implicit, that's one thing to show the picture of it. The other interesting operation, which we'll get to now, is to create them. You in order to, for instance, for training, you say that this bounding box here, you have to give the bounding box, and you give a tag or a label in the sense of training label, not label as a.
Yeah, I understand. Right. That somehow relates to our annotation stuff, which we are supposed to be talking about in a minute here. I would assume that you can use annotations as the raw material for training.
Yeah, I think so. And
which, by the way, is not something Classify, for example, deals with right now. Okay, let's keep going here. Okay, another comment from Ali Hashmi, for example, in fluorescence microscopy. Yes, right, agreed. Okay, next comment. Callouts should work in highlight image.
Yes, this part of label stuff.
Okay. Oh, here's another one. A round should work in color space plot or chromaticity plot. What is color space plot? There isn't that. Am I confused?
I think he meant chromaticity.
Oh, okay. Good point. Yeah, a round should work in chromaticity plot. We're not there yet. Okay. Can you do image segmentation as well as simple bounding boxes? I think the answer is yes. You can make masks and so on. Somebody commenting that different people have, particularly the females of the species, have different numbers of color cones. It's an X-linked trait. And yes, the mantis shrimp. We do not support the mantis shrimp market at this time. It has some ridiculous number of color sensors. We do have some things that emulate dog vision, don't we?
Yeah, the plan was to move on with some other animal vision. It just never got to the top of our priority list.
How do we do bees or the mantis shrimp or whatever, which have things in the ultraviolet? I'm totally confused.
Yeah.
I think it's hopeless.
Yeah, I mean, but there are other things. Satellites also have vision in other.
Of course. I mean, we nicely support multi-channel. I mean, hyperspectral imaging has still not really caught on. I think it might finally catch on when people start, instead of just putting the masks, by the time the CCD camera resolution is unbelievably high, you might as well put masks other than just RGB in front of the pixels. Somebody was showing me that some of the applications of things like food freshness and so on that are easy to find spectrally.
Right.
Yeah, I just don't think we've yet. Okay. Somebody with a cute RGB. You should look at this from the live stream. A pointer to the community. Okay. Question: when should users expect functions like contrast enhancement? I do not know of these terms.
I think it's the good time actually with image adjust updates. I should look at those as well. I saw the comment. I'll make a note.
Okay, so those are basically things that are part of image adjust, or they're different?
Yeah, they are basically different kinds of contrast enhancements. Stretch, basically make light lighter, dark darker, and so forth.
But so why does image adjust not essentially have, for other things we have transfer functions, like for image 3D rendering we have transfer functions. Do we not have a transfer function? I thought we did have a transfer function. It would be
useful, even like nonlinear gamma or arbitrary gamma corrections with curves that we can control and things like that. We have all seen GUI elements for that, right? You're right. It is time to look at all of those as well.
But I thought we had a function that just took different channels and mapped them.
Histogram transform.
Okay. That does.
And this maps histogram of one image to the other one, and the histogram transform interpolation, I think, is the one that gives you the interpolation function.
Right, but what you're saying is, okay, so the question is, can we parameterize these adjustments? Okay, anyway, separate thing. Okay. Okay, comment here, there's no easy way to make masks on images for training data. I think that's what we were talking about, that we want to be able to do that. And the only question is how that feeds into the way that Classify works.
But I think that's a good use case. There are other good use cases for these annotations, if you like, but that, for machine learning, tagging, and training, it's good use case.
Right. I should add to our list for I keep this list of potential projects for the summer school and student projects and so on. We should add some about multispectral imaging, because I think there's some interesting things to try to do. Like, for example, standardization of the false color for infrared and so on, which we've never done. If you can just send me back mail about that, Manu, I'll add it to my list.
Okay.
Okay. And I'm not going to discuss how do you visualize the different photoreceptors in the mantis shrimp. I have thought about that in the past. It's an interesting never mind. I said I would not discuss it. It's an interesting case of, how humans represent things or think about things that humans cannot directly perceive. Okay. All right. Let's keep going here. Inverse spectrogram. Okay, let's see. There's questions about using deformable splines for making masks. People using Fiji for image processing. I don't know what that means.
Fiji is another software. I think he's suggesting some kind of interactive tool to specify splines around, say, the region of interest, and then use that as a mask or initial marker for some segmentation.
Which is a question of our drawing tools, which we certainly have, but they're just kind of crummy. And in fact, you should this.
But it doesn't require drawing, and this would be image, attached cell for image. To just put in a.
No, I understand that. This. If Noah is working on those things, you might add that to the list.
Okay.
Okay. Let's see. Questions about stereo images and masks for objects in stereo images, which I don't think we're dealing with very well right now. Is that true? I mean, we don't have a good. We don't have a wrapper. We could one day have a wrapper called stereo image, symbolic wrapper. Mm-hmm. Would that not make any sense? I mean, we have images with depth maps, right? We can do that, but I don't know how we represent those.
We talked about having a special construct for that.
That's what I think we should do, yeah. And possibly a special construct for stereo image, which would have partial information of that kind.
Right.
All right, we're going to switch gears here to inverse spectrogram. So are you, okay, so inverse spectrogram. So if I say something like, I do an audio capture. Hello, hello, hello. Okay, so now I say spectrogram of that. Wait a minute, isn't inverse spectrogram the spectrogram array? I have to try this. Let's see, if I do speech recognize, I wonder if it's going to work. So speech recognize %37, right? Okay, but now what does inverse spectrogram do? That's operating on, that's an interesting.
That too fast.
Yeah, I said it too fast. I'm just surprised that the language model could generate that. Anyway,
So you really wanted a spectrogram audio function that takes the spectrogram, which is not going to work with that color function we're using in spectrogram, by the way. You should probably do spectrogram of that color function grayscale. You really wanted a spectrogram audio that takes that spectrogram, the power spectrogram, and generates the audio back.
Well, I thought that was from a spectrogram array.
That one gives the data under spectrogram.
No, I understand, but inverse spectrogram array would make more sense, right?
Oh.
I mean, inverse spectrogram from an image seems completely crazy, doesn't it? How do I get the spectrogram? Okay, the spectrogram is kind of end of the line. It's just a picture, right?
Yep.
But spectrogram array, by the way, this thing with the cursor not becoming a vertical I-beam is driving me nuts. Did you already report that, Manu, during this meeting?
I would do that, Stephen.
Okay, but all right. Okay, so spectrogram array is going to make some giant array. Okay. Why isn't this a numeric array object, by the way?
We can make it. We didn't have numeric arrays when we introduced this function, but also I think we are staying a little conservative, not introducing numeric arrays from all functions.
Numeric arrays are not mature yet, Stephen.
Yeah.
In terms of what you can actually do with them.
Okay, fine. All right, but so one day this might be a numeric array.
Yeah.
But then the idea here is that inverse spectrogram operates on this thing. Is that correct?
Correct.
Okay, so if I say inverse spectrogram of that, I'll get a stupid error.
It jokes. Okay. Well.
Why? Well, what is it supposed to be fed?
Real values. You inverse spectrogram really expect the power spectrogram, not the complex values. I guess I can make a case for this to work as well.
It should work, yeah. But okay, so how do I get the power spectrum out of this? Power spectrogram out of this?
Run an apps or squared.
Okay, this is really weird, if I might say so. So, okay, so let's take abs.
But actually, we did have examples that you wanted to convert the image to audio or to a list.
That's what was your highest on your wish list, Stephen.
Yeah, I'm kind of surprised.
Okay. All right, well, let's try this anyway.
And then you still get numbers back.
How do I get audio?
The idea is that this is.
And then I say audio of that. Is that
correct.
Right?
Yeah.
Oops.
Yeah, one other thing is we can't
you
hear
probably
it.
Can't hear it. I wonder how I set it to be able to hear it. It sounds like I can imitate it. It goes.
Yeah, well, the thing is that when you create the spectrogram, you transpose and get the half. So you actually have to implement that from. So really, the assumption for this inverse spectrogram function was that we are giving the image of the spectrogram. So already the transposed half, chopped.
Right. So hold on. So you're telling me if I take that spectrogram there and I say inverse spectrogram of that image.
Yeah. Carlo and I have talked about this. Maybe this doesn't work. But
it does work. Yeah. Okay. Go on.
Yeah. We'll open the ref page for that. Maybe that would help. Again, since you hadn't seen this ever, I didn't put it in the builds. You should open it in CBS. We can make rasters work, graphics rasters, and get the data out. The problem is with these default or any arbitrary color functions that are not.
Okay, there's many layers of weirdness going on here. Okay. I mean, the basic thing that we want to be able to do is to take a spectrogram. Let's say you artistically create a spectrogram, and then you want to basically generate audio from the spectrogram. Mm-hmm. So the question
is, look at the application example. Sorry, I should have moved that up.
Well, not necessarily, but
all right. That's
so there's a baboon. Okay.
Yes.
And you're telling me that I can now listen to the baboon.
Sure. It should be mostly noise.
It's mostly noise. It's not a very. I mean, I was expecting it to sound like a baboon. Never mind.
Well, eventually we'll image identify that and then we synthesize.
Yes, right. Okay. What is this now? I'm hearing music from that. But okay. Yeah. Okay. What should this function actually do? This function should be taking.
So at the core, but there's some administration around it, which I think is a little funky. But at the core, what it does, it takes the real spectrogram and it tries to reconstruct the phase. So it has to fill in with models what the data doesn't provide.
Yes. But okay, but there's two different things. I mean, one is taking the true spectrogram and just reconstructing audio from it, the true complex spectrogram.
Right.
That one now are under short-time Fourier family. That we already settled on. We have short-time Fourier, which also keeps what was the original object, whether it was a list, an audio, or a time series.
Okay.
And then we have inverse short time Fourier. So if you do have the phase data, that's the proper way of.
Okay, but look, there's got to be something in the family spectrogram array which is giving you phase data. I mean, I don't understand why spectrogram array gives you phase data and spectrogram does not. In the sense, and sorry, I said that wrong. Given that spectrogram is losing phase data, should spectrogram array also lose phase data, or have some way to specify to lose phase data?
Makes sense. Because especially now, that is a redundant functionality with short time Fourier. Short time Fourier creates a short time Fourier data object.
I don't know this field well enough to know. When you say spectrogram, do you expect complex phases or not? I would have thought not.
Spectrogram, no. The spectrogram is just a plot.
Well, then maybe spectrogram array should just be the, maybe it should be the case that spectrogram.
Well, I mean, things are different now because at the time, as Shadi said, we were trying to we know that the plot losing half the data.
Yes.
Okay. And so spectrogram array was trying to fill that gap. But
yes.
the real thing is short-term Fourier transform. That's what one should be using for sort of full fidelity.
Yes.
It has many applications.
Yep. Yes, so, rather than spectrogram. And spectrogram is just show me a basic picture. But then the problem is the inverse of that is given a picture, what does the sound, is surely worthwhile. And both cases of draw me a picture, because most artists don't draw in complex values, so to speak. Draw me a picture and then infer the phase data and play it. And potentially, well, I think that's the most common case. So is it the case that spectrogram array, if I were to do, okay, so what happens if I say now abs a %40, and then I just say array plot of that? Do I get the spectrogram? No, I get this bizarre thing with the two different branches of the spectrogram.
It is the duplicated spectrogram.
I know. So why isn't it the case? I would have expected that spectrogram array would basically give me the numbers in the spectrogram. Now, I admit that the plot, in other words, the thing we want to be able to do is to let people essentially make one of these plots themselves, right? So that's, what would the most natural way of specifying the numbers that appear in there?
In the spectrogram?
Yeah, I mean, it's kind of, obviously it's weird. I mean, if it's an image, for example, let's see, which way does an image coordinate system go? Our image coordinate system goes up, doesn't it?
That's similar to what you see in that spectrogram. 0, 0 is at bottom left.
Right. So 0 time 0 frequency, bottom left.
Yep.
So if it was an image, one could imagine, it's a little weird. Well, okay, so one could imagine some kind of spectrogram image. I'm not happy with this. Right, and inverse spectrogram image. It's not quite right. But that's the type of thing. I mean, like your baboon, for example, that's presumably you're grayscaling the baboon and then using it to render the intensity in those positions. Is that correct?
Yes, exactly.
So, for example, if I were to take that friendly creature, why do you need to, okay, you're doing an image rotate here.
That's now built in. Again, not updated, my bad.
Okay,
if you just pass the image to inverse
spectrogram. But if I rather want to take this thing, okay, so let's take this guy and let's edge detect him, because then I think it won't be noise. Well, it might still be noise. It's got a very fluffy creature. How do I get something? I have edge detect a point of like 4 or something here. Okay, whatever. Okay, there we go. There's the baboon sketch, the Picasso baboon. Okay, so now I feed that to inverse spectrogram, right? I say audio of inverse spectrogram of this. Is that correct?
Correct.
Oh, this is really cool.
Sounds
can't
like a
hear it.
baboon.
You can put it
Did
out on Zoom if you like.
How do I do that?
Expand your audio object with the arrows.
Make the big interface. Now click the speaker.
You'll have to change the device.
You have to change. No, Stephen, no. Go back out.
What do you mean by out? This one?
Yeah. Now click the speaker. There.
Zoom audio device?
Yeah.
Yes.
Okay, this could be bad, everybody. Can anybody hear anything?
Oh, you have to also share your Zoom. On the very top, it says add share or something.
Where?
New share. Yep. Sorry, we don't see your Zoom.
Share computer
Controls.
sound.
Correct.
Wow.
Sounded like a bird to me.
Yeah, it's the baboon's friend. Okay. Okay, so I feel like saving this file because it's got enough bizarre, weird, interesting things in it. Okay, hold on 1 second here. Okay. All right. So look, with respect to the spectrogram thing, we're not, I mean, this is really a shame because you're saying with a pure image here, we can get the audio out of the image. But how do we get an image from the ordinary spectrogram? How do we get an image from this spectrogram?
So, I mean, it's a little ornery, right? I mean, because you have to then get rid of the
decorations.
Yeah, the decorations.
Arguably, spectrogram should have some argument where it just gives an image.
Grayscale as well, because color function is in the way too.
Yeah, I understand. Oh, I didn't know we had these. That's a sensible idea. Well, I'm not certain what we should do here.
I mean, so it's not as streamlined as it can be but if you get rid of the frames and stuff, you just get the image.
Really hacky. I mean, that's really, really hacky.
No, I agree.
Is this an image, in fact, or is this?
No, it's
graphics.
Yeah, so that's a real hackalola there.
It's a plot. It's a plot. Yeah.
Is it? It looks bitmappy.
It's a raster. It's a graphics of a raster.
Yeah.
Okay, I see. It's vector graphics of a raster.
Yeah. And we experimented a little bit taking the raster out. It's always RGB, even if even if we use a grayscale color function and so forth. We decided to just leave it out for now and just go with images or data.
Well, I don't understand the data case. I don't understand the format of the data. Is the data a list of intensity value? I mean, is it what it should be is going up from 0 at each row. I mean, at each time value, it should be the intensity for frequency 0, blah blah blah, up that way, right?
That makes sense. Yes.
In fact, then what it is it's if this was an image, those values will be arranged in the same way that they would be in the image, left to right, bottom to top.
So you want the inverse spectrogram of image to be equivalent to inverse spectrogram of image data of the image.
That's what I'm suggesting, yes.
Yeah, I discussed that to Carlo. I agree that that's a lot more intuitive.
Okay,
let
the
us
issue
reiterate that again.
Okay, so then the question is, how can you get an image out of spectrogram? We've never really had that issue of getting an image from, because we've never tried to process things from an image. But I think this design for inverse spectrogram we just described is reasonable. And if it is, it will normally not take complex values, but if it is given complex values, it will use the complex values.
Okay. Yep, that makes sense.
Okay, so then the only thing that remains here is to see how spectrogram can generate an image. I mean, there's a hacky way to do it with method arrow image or something, but that's really hacky. Roger, do you have any thoughts about this?
And I think it violates our design rule to changing type.
Yes.
I think it sort of has to be an argument just about if you want it.
Yeah, I agree.
You know, it's like format almost, like we have for many other functions, like what is the output that you want? But it's all filled up with a bunch of other things, the arguments there.
Yes. Which are necessary. Except, I mean, the problem is, as we've discussed before, inverse spectrogram requires knowing, frequency, what the actual values correspond to, right? How have you done that here? I see. So you're basically mirroring the arguments here.
That's correct. Do you think some value range specification is going to be useful there? I think so.
Yeah, I think so. But okay, what is the role of spectrogram array? What is spectrogram array? Why isn't spectrogram array?
Spectrogram array used to be what short-term Fourier transform.
All right, so maybe
better.
spectrogram array should be the image data that can be fed to inverse spectrogram. Or the image data like array that could be fed to inverse spectrogram.
I don't think we want to change the dimensions of spectrogram array so that it's transposed like what the data under spectrogram is. People are very much used to seeing frequency.
Sounds to me like spectrogram array is going to be a dead function soon.
I think so as well. That's my guess.
But
it's also released version 9. I would be a little worried about changing.
Okay. Well, I mean, we just can leave it.
Yep.
Well, so the possibility is spectrogram image is a possible thing. If we think that's useful, we think it's sufficiently useful, we can make a spectrogram image produce a grayscale image.
Maybe a plot theme can control that as well. An obscure setting.
That's really obscure. That's. I mean, this is definitely in the. Well,
I mean, it all relies on sort of how common and useful is that case.
I know, because what I'm imagining is, here's what I'm imagining, that people take the spectrogram image, they do image processing operations on it, then they do inverse spectrogram on it to play it.
Correct.
That's
well, in that case, I think we should actually have spectrogram image.
Okay.
Because then that feeds that workflow. Here's a way to generate an image, process, and go to town.
Fine. Let's do it.
Okay.
Okay. And okay. We have run out of time here, except let me just take a very, very, very quick look at web audio search. Is it in this where do I have to look for it?
Ref page in CVS, or just play with it. It should work.
Well, okay. So let's try one thing here. Okay, so if I say web audio search for, I should probably regret this, but anyway, baboon.
Oh, okay. Something going on with the Service Connect. I don't know.
What does that mean? That's really weird. I mean, does that mean that my how can that possibly be working? I'm, no, there's nothing wrong with my connection. I don't understand that.
Moving Freesound to the cloud so that we can, we're just basically patching this correctly for authentication and things like that. I'm guessing in the past few days, it must have changed.
All right. Okay. Well, listen, we have not finished here, unfortunately. We're going to need yet another meeting.
I think really this is annotations we have discussed. If you briefly look at what Roger has in the notebook, 4 symbols are going live in 12. That's the first set: annotation delete, annotation rules, audio annotate, and audio annotation lookup. It's going to be very audio specific in 12. And 12.1 is going to do the real release of annotations where properties are renamed and more objects are going to support annotations.
So you understand?
Arrow,
No, I'm just saying that what do they correspond to in the property framework when there was something corresponding to it?
Okay.
I guess the arrow should have gone the other way.
Yeah, okay. Annotation rules. Okay, audio annotate, yes. Audio annotate lookup. Did we discuss that? Audio annotation lookup.
Not really, but this is a very rich lookup function that allows for looking for any tags at any time or time interval for any value. It's a very useful lookup function. This is all experimental.
So in general,
I kind of expect, it wouldn't surprise me, Stephen, as we do more annotation across more objects, that we'll have lookup functions that are particularly useful for that class of object.
I understand that, yes.
It wouldn't surprise me, but it's what it seems to me that it's going towards.
Right.
But we have too little of our experience base is a little slightly small yet.
I understand that. Okay, 2 questions from our live stream, and then we need to wrap here. From Alvaro O'Byrne, asking, is spectrogram of inverse spectrogram of X the identity? And the answer is not precisely, because spectrogram image of inverse spectrogram of an image would give the same image back again, correct? No, not necessarily. No, it's not. Is that correct? Yes, it is correct. But it depends on the way that it does complex value interpolation, right?
It depends on how it reconstructs the phase.
Yes. But in other words, so the phase deconstruction, so to speak, or the phase removal, the question is the phase removal the inverse of the phase? When you get rid of the phase again, do you get back? Okay, you've got a power value.
I see what you're saying.
Right. Does that work correctly? So in other words, you've got a power value, you reconstruct the phase, you spectrogramify, which means you're only getting the power value again. Do you get back to the same thing you had before?
It seems like we should, but we should check.
Agree. Right. Okay. Question, will web audio search cost money like web image search? What's the answer?
Unfortunately, no. And unfortunately, yes, in the first release, because it will do edit stuff. Our goal is another subsystem which will allow it to be not cost money, but you will supply credentials for the services that you want to use. You only need to do it once. You store it in sort of the front end settings, and you can manage the services that you want to activate or not activate.
Well, using system credentials and using all of that whole apparatus that we have for storing, I mean, Service Connect, right now, you give your credentials when you do the service connection, but with the fact that we can now hook into system keychains, you don't have to do that.
So that's an important aspect there, what you point out, Stephen, because if you're going to store your So the point is that if you store your credentials for the different services that we hook up to web audio search, then it's free. But then it needs to be stored securely.
Yeah.
And so there's a big there's a bunch of internal projects going on to make sure that we can responsibly store credentials.
Wait. There's one project, which is the system keychain project. I mean, you don't need to do your own system keychain project.
No, I know we don't. We're waiting for it, but it isn't finished.
Is it not finished? I mean, I thought I could say system credential.
We were trying to use it, and
it didn't work properly.
Shoddy?
Actually, I'm not sure we really properly tried because I wasn't sure it's there and operational working.
Well, that's bad.
But that's the plan. That's the plan to hook up to that and use it. Do you want to quickly see the results of web audio search? I feel like we are really done with the wrap-up review in order to avoid a separate meeting for just the one function.
I think we've got a few items here that we're trailing anyway.
Not for 12. I think this is, we decided pyramids are going.
Okay, hold on. Wait a minute. Image feature track function has a lot of potential for tracking. Okay, that's good. You can add some option to get rid of occlusions for a certain number of frames. For example, okay, this is details for you about image feature track. Okay, you want to show me something on the screen?
Yep.
Go ahead.
As you suggested earlier, web audio search now has the second argument. The default is dataset. So for the baboon, I get the dataset of 3. The function has max items that maxes to 10 by default, but for baboon.
Hold on. I'm still absorbing this baboon here. Okay. Okay, so you did a web audio search. What is player here?
So this one allows you to play the single audio.
Okay.
And then to pick from the ones. The picker is going to be the gallery view that you can actually say, I like this one after maybe you played.
Wait. What are those pictures of? Are those spectrograms?
Those those are spectrograms.
Why aren't they on our default colors?
These
come from the service.
Yeah.
They come from the service, Stephen. There are thumbnails provided by the service.
Okay.
Not produced by us. But the one thing that's super important for both of these, they don't pull in the audio. They have links to it, and you stream it through that player.
Otherwise, okay.
No, you can get it. You know, that's
so for example, if you want to pull in that first thing there, show me how to pull in Ming's baboon.
Sorry, which one? So I was just going to go to free sound to show you this or
I
that.
Understand. Okay, so it's a baboon from the Wellington Zoo. Oh, wait. Show me the 2 cases there.
This is the spectrogram. They also have the waveform.
Okay. Why don't we have a green and red spectrogram? Why do we only have a one color, one hue? Do they have more information in there? Or is that just no? They don't have more information.
Just a color.
Different color. Yeah. Okay. Do we have that color function as well?
Red, blue, green kind of a color function. I don't know.
Okay. All right. Okay. So let's go back here to show me the workflow to get that.
Ming's baboon. Yes. Yeah, so copy and paste. Copy. Paste. There it is.
Okay. So now if you say spectrogram of that. Why do you have to say sub 1?
That was a list. Oh, no, but...
Yeah, you forgot to evaluate that. Okay. No, but I'm asking, why does spectrogram not take a list and return a list of spectrograms?
That's I guess, never-ending question. How many of the functions should work on a list and return a list? We can make that work.
Well, or unless the spectrogram of a list should mean something different. I think we should not jump to doing that because I'm not sure what it should mean. Okay. That's a weird sounding. That's a rah rah type sound.
Well, you can play it, Shoddy, for us. You know, so we can hear it.
Yeah.
Shoddy?
Yeah, she's
am.
playing
I
it.
am,
She's
I am.
playing it. I heard it. Okay. My imitation wasn't very good. Okay. All right. Is this really everything that we need?
I think we managed to, yeah. Yes.
That was a terrible sound.
It was better through the microphone, not through the Zoom. I think this is it, Stephen. If I'm correct, going through my notes from today. We
Okay.
don't need
Great.
to come in for 12.
Okay. Sounds good. All right. Well, thank you all. Thank you for lots of useful comments on the live stream and encouragement. And talk to you all soon.